So looking here at 19.4. Now there's an awful lot of writing here. So from a bucket of spring water containing dissolved calcium chloride and calcium hydrogen carbonate, 500 centimetres cubed of the water were accurately measured into a beaker and then boiled for 30 minutes. When cool, the water from the beaker was filtered into a 500 centimetres cube volumetric flask. The ionised water was then poured through the filter paper into the flask, and finally the flask was made up to the mark. We're then told the water from the volumetric flask was then titrated in 100 centimetre cubed volumes. So I have 100 centimetres cubed of my calcium ions, and I'm told to use a 0.01 molar EDTA solution. The mean titration was 6.0 centimetres cubed, and then when the measurement was repeated using again 100 centimetres cubed volumes of the unboiled water, the mean titration was 19. So I'm just basically going to look at two things here. I'm going to write in the unboiled, which is 19.0 centimetres cubed, and finally then the boiled, which I'm told is 6.0 centimetres cubed. What I have to do here is in part VI, I'm asked to calculate the total hardness of the water in the bucket expressed as parts per million again of calcium carbonate. Okay, so the total hardness in the sample is going to be the sample that was unboiled. And then the second part is calculating also the hardness that was due to the presence of the calcium hydrogen carbonate. I'll come back to that in a minute. So firstly, what I'm going to do here is I am going to work out firstly the amount of hardness in my unboiled water, which I'm just going to label unboiled, and then I'm going to work out the concentration of my hardness in water in my boiled sample. Okay, so if I look at my unboiled, 0.01 molarity is moles per 1,000 centimetres cubed. In my unboiled sample, I haven't used 1,000 centimetres cubed, I've used 19.0. So I multiply by what I know, 0.01, multiplied by 19, divided by 1,000, and that gives me 1.9 by 10 to the minus 4 moles of EDTA. My ratio then, H2X2 minus is to Ca2 plus is 1:1. So if I have 1.9 by 10 to the minus 4 moles of EDTA, I also have 1.9 by 10 to the minus 4 moles of my hardness water sample. So that's 1.9 by 10 to the minus 4 moles, and that is in 100 centimetres cubed. I'm told in the question I use 100 centimetres cubed as my volume. So to find out what's in a litre, multiply by 1,000, divide by 100, and I get 1.9 by 10 to the minus 3 moles. Next then, I need to work out my grams per litre, and my grams per litre is going to be number of moles equals mass in grams divided by my relative molecular mass of calcium carbonate, 40 plus 12 plus 16 by 3, which gives me 100. So 1.9 by 10 to the minus 3 multiplied by 100 gives me a gram per litre of 0.19, and then I have to convert that into ppm. So in order to do that, I multiply by 1,000, and that gives me 190 ppm. Okay, I am then going to repeat the exact same procedure this time with my boiled water with my mean titration of 6.0. So again, I have a molarity of 0.01, that's moles per 1,000 centimetres cubed, and in my boiled sample this time I only needed 6.0. So 0.01 multiplied by 6 divided by 1,000 gives me 6 by 10 to the minus 5 moles. Again, that is my number of moles in my EDTA. So if I have 6 by 10 to the minus 5, using my ratio of 1 is to 1, that's 6 by 10 to the minus 5 moles. So 6 by 10 to the minus 5 moles, again, is what's present in 100 centimetres cubed. And I'm going to work out my moles per litre, which is 1,000 centimetres cubed. Multiply by what I know, divide by the bit left over, 6 by 10 to the minus 4 moles. Okay, next then, again, working out my grams per litre, which is my number of moles, 6 by 10 to the minus 4, multiplied by my relative molecular mass, which I've worked out here from part A, so I'm not going to do it out again, and that gives me 0.06 grams per litre. To multiply that by 1,000 in order to get it into ppm, and that gives me 6 ppm. Now, sorry, it doesn't, it gives me 60 ppm. Okay, now, if we just come back to the question, we are asked here, firstly, calculate the total hardness of the water in the bucket. So my answer here, this is the total hardness that's present in the bucket. So my answer to the first part is going to be 190. Now, I am then asked to calculate the hardness that was due to the presence of calcium hydrogen carbonate. Remember, calcium hydrogen carbonate is the amount of temporary hardness in the water. So that means the temporary hardness, remember, can be removed by boiling. So the amount of the calcium hydrogen carbonate that's present is going to be the amount of total hardness at the start, take away the amount of total hardness that was present at the end. Remember, this hasn't been removed by boiling, so it cannot be a cause of temporary hardness. So my answer there then is 130 ppm.